and I'm definitely happy to be part of it. And I congratulate everyone who's responsible for creating this group, because it'll be a very useful activity to have once in a while, so that everyone can share the learning and their experience, so that it'll be useful for a wider community, right? So before we start, just to give a brief background about myself, my name is Sujay Palavalli, and I'm currently working as a principal solution engineer at Oracle India. Uh, my main background is database administration and engineered systems. So, that's a brief introduction about me. So let's get started with today's session. So, as everyone knows, we will be discussing a couple of concepts about the Oracle Data Guard. And yesterday, I spent a couple of hours to see if I can add a few things related to the latest release, which is the 18.1. So let's get started. So before we get into the main concepts, let us first understand what Oracle Data Guard is all about. So Oracle Data Guard is one of the techniques where we can configure high availability at the same time protecting the data for disaster recovery. The Data Guard provides a set of services that create, maintain, manage, and monitor one or more standby databases. So standby databases are mainly identical copies of the production database. So if a primary database is unavailable due to disaster, the standby database can switch its role to primary, and your applications can start connecting to the new primary and continue the work, right? Apart from that, certain operations like backup and the reports can also be offloaded to the standby. So the advantage of doing this is we can reduce the load on the primary database, and the primary database can take workloads such as your OLTP or your data warehouse or your other important activities instead of burning the CPUs and IOs for backups and reportings, right? So for one primary database, there can be up to 30 standby databases created. So 30 is a very big number, and you can have multiple level of high availability configured, right? So that's an overview of what Oracle Data Guard can do. So let us now understand some of the components of the whole Data Guard configuration. So the key thing is the primary database. The primary database is basically our production database, and we refer the role as the primary role, right? So primary database is the one that is mostly accessed by your application, and the primary database can be either single instance or rack instance. So the picture just represents a brief overview about how a data guard will be configured. So to the left, we have the primary database that transmits the redo, and towards the right we have the standby, which is the identical copy of the primary, and we also have something called the standby redo logs, which we will see later in the session. So the redo stream is transported from the primary, and it is applied to the standby to keep it up to date with the primary, right? So that's basically how the data guard configuration works. So we just saw what a primary database is. Now we will see what standby database is all about. So a standby database is a transactionally consistent copy of the primary database. It is created using a backup copy of the primary database, and we can create up to 30 standby sites, right? So redo transmission and apply is the technique that will be used to maintain each standby database. And like primary, the standby database can also be a single instance or a rack instance. Uh, but when we talk about the standby, we have a couple of options in which the standby can be created. So it can be a physical standby, it can be a logical standby, or it can be a snapshot standby. So let us discuss about each of these shortly. So first, let us see what a physical standby database is. A physical standby database is an identical copy of primary database. When we say identical copy, the on-disk structure, the on-disk database structure is exactly same as the primary on a block-to-block basis, right? So the primary database receives redo, the physical standby database receives redo from the primary database, and it will be applied to keep the standby in sync with the primary database. Okay. Starting from 11G release 1, the standby database can receive the redo and apply it. And at the same time, it can be open for read-only access for either running backups or running reports. So releases prior to 11G release 1 did not have this option. It can either be applying the redo or it can be open in read-only mode. So there was no way to have both at the same time. So this feature has been released starting 11G release 1. And from starting 11G release 2, we can also have patches, the PSUs and CPUs applied in a rolling fashion as well. So this is called standby apply first. So you can refer to the note 1265700.1. It's an MOS note, which is a public note. So you can all refer to this for a detailed description about how this can be done. So we saw about the physical standby. We learned that physical standby is an exact copy of the primary in terms of the on-disk structure. So what is different in logical standby is the physical structure can be different. For example, if you have a table on one particular table space on your primary, on your logical standby, you can have the table in a different table space, right? Only the logical structure will be same, and the physical structure can be different, right? And the technique which is used to keep this logical standby in sync with the primary is called SQL apply. So SQL apply will transform the data in the redo into SQL statements, and then it is executed on the standby to keep the logical structures in sync with the primary database. So we in the recovery technique in the primary is similar to what we do, what happens when we do a recover database. So apart from the physical and logical, we also have something called the snapshot standby. Let us see what a snapshot standby is. So it is a fully updatable standby database. It is similar to the physical standby. It receives and applies the redo. However, it can also be used for doing updates. But the difference is, if you want the redo to be applied and if you want the snapshot standby to be in sync, we have to discard the newly done changes, and then we have to convert the database back to physical standby database, right? So this is useful in a scenario where you need to update our database temporarily to understand, how some application changes would look like. And one of the best use cases is real application testing. So just to give a brief about real application testing, it's a technique where we capture the workload on a primary database or the production database, and we can replay the same workload on either a development or a snapshot standby database, and and gauge either the performance or the application behavior, right? And we also have something called FARSync instances. FARSync instance is a remote data guard destination that accepts redo from a primary database, and then it ships that redo to another member of the database, the data guard configuration, right? So the FARSync instance will only have a control file and the standby redo logs. It will not have its own data files, right? So it will not be applying the redo that it receives. The only job of the FARSync is to receive the redo and propagate it to another standby instance, which could be much farther. See, the main reason why we have this is if say, for example, we have our primary and standby, which are very far from each other, the time it takes for shipping the log and applying it on the standby may be a little more, and that will impact the performance on the primary. If, say, for example, we are using the maximum availability or a maximum protection modes. So to reduce the lag in redo transport as well as apply, a new feature called FARSync has been introduced, which can be placed in between the primary and the standby, so that the redo transmission lag can be reduced, right? So what basically happens is, as soon as the FARSync receives the redo, it acknowledges the primary database to continue with its operations, and the FARSync will then transmit that redo to the recipient standby databases. Okay, so it is also part of a feature called Active Data Guard. So if you want to configure a FARSync instance, you need an Active Data Guard license. So that's a catch. So let us see some of the services that are playing key role in keeping the primary and standby in sync. So the core service is the redo transport service. So what the redo transport service does is, it is responsible for shipping the archived or the redo stream from your primary to the standby destination. So that's the core feature. The redo transport service also resolves gaps automatically. So when we say gaps, it can be created if there is any disruption in the network. So what the redo transport does is, it continuously monitors for the primary and the standby to be able to talk to each other over the network. And whatever archive logs were missing on the standby, it automatically ships it from the primary or another standby site, right? That's the key feature of the redo transport service. And the background process that is responsible for this is the RFS process. It's called Remote File Server. So the next thing is, once we get the redo, we should be able to apply it on to our standby database. So that's taken care by a service called Apply Services. And MRP is the process that is responsible for applying the redo stream to the standby database. MRP stands for Managed Recovery Process. So redo data is applied directly from the SRL. SRL is standby redo logs. as they are filled using real-time apply. If we do not configure the standby redo log, then the redo data must be first archived at the standby site, and then it will be applied to the standby. So this will work like your traditional database recovery process, right? So redo apply and SQL apply based on physical or logical standby. So when we are talking about the physical standby, we refer it to as redo apply. And if we have a logical standby configured, we refer the apply services as SQL apply, right? And then the next important thing is the role transition. So when we say a role transition, the primary database can become a standby, and the standby can become a primary. So this will be mainly done in two cases. Either if you want to do a planned maintenance on your primary, say for example you have a problem with your hardware or some operating system patching or something like that, you can briefly convert your standby to primary database, and you can change your application connections to the standby so that there is not a bigger outage. So once your primary site is up and running, you can switch the roles back. See, we have two terminologies again here. One is the switchover, which is done during a planned maintenance. So when you do a switchover, the best thing is once your primary site is back, you can just do a role transition. When when we do a failover, it means that we have lost our production site permanently, or it might take a very long time to rebuild the site. So in that case, we can do a failover. So failover is a permanent role transition. If we have to again recreate the data guard configuration for the new primary, we have to again create another standby and then re-establish the data guard configuration. So we have another small utility called Data Guard Broker. Although it is a small utility, it is a very powerful utility and very handy when you are managing, for example, one primary and multiple standby sites, right? So the Data Guard Broker is a distributed management framework that automates a lot of tasks like creation, maintenance, and monitoring of the data guard configuration. So some of the things that we can do using Data Guard Broker will be create and enable data guard and set up redo transport and apply services, manage the entire data guard configuration from any system in the configuration. So when we say any system in the configuration, say for example, if we have one obviously we can only have one primary. If we have 10 or 15 standby sites created, if there is one change that has to be done, without the Data Guard Broker, we have to manually log into every single site and do the change, right? So with the Data Guard Broker, you can either be on the primary or you can be on the standby site. And the moment you do the changes, it will be propagated to all the intended sites. Okay, so from one location, you can do the changes on multiple locations. And a very important point is when we are either doing a failover or a switchover, it is very easy to do using the Data Guard Broker. And how do we invoke the Data Guard Broker? Similar to SQL Plus, which is used to connect to the database, we have a separate command line utility called dgmgrl, right? And there is a new feature in Data Guard Broker configuration. It's called Fast Start Failover. Of course, it's not an 18C feature. It was released much earlier. Sorry. So what this fast start failover does is it will be continuously monitoring the availability of all the sites in within the data guard configuration. And when it feels that you know something is not right and your application might be impacted, the data guard broker will automatically switch the roles so that you do not end up you know in an scenario where you have an outage and you don't notice it. So a data guard broker data guard broker can sense if something might fail, and it will automatically take corrective actions to make sure that your application does not encounter a longer downtime. And this is completely automatic. There is no intervention whatsoever required from a DBA, right? So we saw briefly about what the data guard configuration is and the different types of configuration that we can have in a data guard configuration. So now let us see what are the different modes in which we can have the data guard configuration set up, right? So the first option is called maximum availability. So what maximum availability offers is it provides the highest level of data protection without compromising the availability of the primary database. Okay. The transactions on the primary database do not commit until all the redo data that is generated is either received in memory or written to the standby redo log on at least one of the standby sites, right? So we do not wait for the redo to be propagated and written to all the sites that are configured. If it is written to at least one site, then we can continue to commit our transaction on the primary. If the other standby sites do not receive it from the primary for some reason, they will fetch the redo data from the first standby that received it, right? So that is the default behavior in which maximum availability works. So when we say maximum availability, the redo on the primary that is generated should be propagated to at least one of the standby database. So that's the key point of maximum availability. So let us say that there was some network outage and the redo from the primary could not be written to any of the standby sites. So what happens in that case is the configuration downgrades itself to maximum performance mode, and then the transactions on the primary would continue to commit, right? So in this situation, there is a gap in the redo transmission from primary to standby sites, right? And maximum availability uses synchronous data transfer. So when we say synchronous data transfer, the primary site would wait for an acknowledgement from the standby sites to check if the redo has been written to the disk or not. Okay, and the maximum availability ensures that there is no data loss, right? So that's about the maximum availability. So the next important feature or important mode in which the data guard configuration runs is maximum performance. So maximum performance is the default mode. It provides the highest level of data protection possible without affecting the performance of the database, right? So when we say without affecting the performance of the database, the primary database need not wait for the transaction to be committed. It can just continue as soon as it the redo has been flushed to the online redo logs on the primary. It need not wait, or it need not check whether the redo has been transmitted to the standby sites or not, right? So the redo, this we refer to as asynchronous redo transmission. So when we say asynchronous redo transmission, the primary would send the redo data to the standby sites. However, it does not wait for an acknowledgement from the standby sites to understand if the redo has been successfully received and returned to the disk, right? Uh, the disadvantage with this mode is the data protection that it offers is slightly lesser than what the maximum availability offers, right? So the next thing is the maximum protection. Uh, this maximum protection mode offers the highest level of data protection. The reason is the the redo data that has been generated on the primary has to be written on at least one of the standby sites. If there is a network disruption, for example, between the primary and standby, and if the redo uh, is not being transmitted to at least one of the standby sites, the primary database will be shut down, right? So that's the disadvantage of this protection mode. Uh, this mode should be used only for those applications that requires the highest level of data protection and can tolerate some outages, right? Because the risk in this mode is if the data is not, the redo data is not transmitted to one of the standbys successfully, the primary database will shut down itself, right? So how do we configure these protection modes? So the protection modes mainly differ in the way we configure the archive log destinations and some of the parameters we use for to control how the redo is transmitted. So we will see some of all those parameters when we come to a section where we see how we create the physical standby, right? And there is also something called client failover. These features were released in the newer releases. These features were not there in 10G or 9i. So the client failover is a high availability architecture that requires a fast failover capability for DB and the DB clients as well. So when we say the DB clients, it's basically your application connections. So what it offers is a mechanism to notify if there is any failure, and it cleans up the stale connections, and it will also help the application to reconnect to the new primary database and continue the operations, right? So the data guard broker is the framework that provides these capabilities, and we do something. We get this through something called fast application notification and fast connection failover. This is similar to what you get in the real application cluster setup, right? So we have FAN and FCF even on the rack setups as well, right? And there is a very exhaustive information in MA best practices white paper. So you can go to oracle.com/go/MAA. MAA stands for maximum availability architecture. So please go through this white paper when you have some free time, and you can get very good information about the maximum availability architecture, right? And apart from the failover capabilities, we also have something called application continuity. So this is an Oracle database feature that enables rapid and non-disruptive replays of requests against the database after a recoverable error that made the database session unavailable, right? So this is again built into the database, so there's no manual intervention required. So what we are what it basically means is once the data guard configuration recovers from a failure, the application connections will be reestablished, and your application can continue to access the database. Right? That's what we are basically trying to say. So if you if you want this capability to be active, it should be it is supported only for the switchover to physical standby DB and fast start failover to physical standby database in maximum availability mode. Right? It is not available in obviously in max protection or the performance modes. So for more information about the application continuity, please refer to the Oracle Real Application Cluster and the deployment guide. So now let us get a little more in detail about how to configure the data guard configuration. So about the hardware, operating system, and the software requirement, we starting from 18C, we have limited the operating systems to the Windows 64-bit, Linux 64-bit, and the Oracle Solaris. When we talk about Oracle Solaris, it can be either running on the Spark systems or an x86, which is Intel-based machines. So they have to be 64-bit. And since 18C is the latest release, I've added 18C as the database software that we need, and it has to be enterprise edition, right? And there are some of the other software requirements that we need to meet before we start configuring the data guard. So the primary and the standby sites should have the same database home version, including the patches that are applied. So the primary, if say for example, the primary is on 11.204 and some bundle patch, the standby site is also expected to be on the same level unless we are doing a rolling upgrade, right? That's the only scenario where the versions can differ. If not, they have to be on the same release and the patch versions as well. The compatible parameters should be set to the same value on all the databases in the database in the data guard configuration. The primary database should be running in archive log mode, which is very obvious, and the force logging should be enabled, right? So there should not be any redo generation that can be omitted. Say, for example, if you create some objects in no logging, and if you load some data, that will not be transmitted to the standby, and that will result in inconsistent data, right? So the primary database can be either a single instance or a rack. We saw this earlier as well. So the standby databases can be single instance or rack, and it can be a mix of physical, logical, and snapshot standby types, right? So for example, you can have one primary and you can have 3 standby databases. One of them can be a physical standby, one can be a logical standby, and the other one can be a snapshot standby. So this type mixed configuration is absolutely supported, right? So to administer the data guard configuration, you need sysdg role if you do not want to use a sysdba connection. So you should either have the sysdg role or you should be connected as sysdba. Sorry. And for placing your data files and other files, it is recommended to use ASM and OMF. OMF is optic. So now let us take a look at how your directory structure can be on your primary and the standby sites. Uh, so if you have the directory structure on your standby similar to that of your production, oh, I'm sorry. The first example is if you're placing your standby database on the same system as your production system, then the directory structure should be completely different because we do not want the files to be overwritten. So to enable that, there are two parameters called db file name convert and log file name convert. So we need to use these parameters and specify uh, the equivalent directory where you have the data files or the log files saved. So what happens is since the dictionary will have the same uh, path as your primary database, we need some technique to convert them to a different location. So for that purpose, we use db file name convert and log file name convert, right? If the standby site is on a separate system, and if your directory structure is same as your primary, there is absolutely no change or there's no need to use db file name convert and log file name convert. The configuration is straightforward, right? If your standby is on a separate system and the directory structure is not similar to the primary, for example, you have your data files on U01 on your primary, and on your standby, your data files are on U02. Then we need to use db file name convert and log file name convert, similar to the first case where we had the standby on the same site, right? So as we discussed earlier, we need to enable archive log mode on the primary database as well as force logging. So force logging prevents load operations from being performed in a non-logged manner. So this will take precedence over uh, specifying no logging at the SQL level, right? Even if you say no logging when you're doing a load, that will be ignored because we have enabled force logging at the database level, right? And in 18C, there are two more types of logging available. It's called standby logging for data availability. So what happens is instead of propagating the load in the redo stream, there will be a separate connection established and the data will be written directly onto the standby database. Probably something similar to using the DB link, right? So this will save a lot of network traffic as well as a lot of time, because transmitting redo might take more time than establishing a direct connection and writing the data onto the standby. So in this technique, there are two variants. One is data availability and one for improving the load performance, right? So the basic difference is similar to the maximum availability and maximum performance. The commits on the primary will be delayed a little bit because it kind of does in a synchronous way. So an acknowledgement from the standby side is required. And when we are talking about standby logging for load performance, it will be done in an asynchronous way. Of course, with its own limitations, it can have some missing data. But of course, in the latest releases, since we have efficient techniques to manage the gaps, it will eventually be fetched and applied onto the standby system, right? So standby no logging for data availability, standby no logging for data load performance are new features in Oracle 18c. Can you guys hear me? Okay, all right. Thanks. Before we get into the creating the physical standby, are there any questions? All right. So let's continue. So as part of creating the physical standby database, we also need to establish authentication to enable the redo transport. So the Oracle Data Guard configuration uses the Oracle Net sessions to transport the redo data as well as control messages between the members of the Data Guard configuration. So there are two methods in which that authentication can be established. One is the secure socket layer protocol. SSL is generally used when we have OID. It's called Oracle Identity Management or the management. And the most common technique used for establishing the authentication for redo transport is using the remote login password file. So I guess everybody knows about the remote login password file. You just need to copy the password file from your primary to all the standby sites, and that will help in establishing the connections for transporting the redo, right? Prior to 12c release 2, the problem that we had with the password file is if somebody changes the password file on your primary site, the redo transport services would fail on all your standby sites. So we have to manually copy the password file to every single standby site. So to avoid this, starting from 12c, there is a new feature where if you do any change to the password file on the primary site, the changes are automatically propagated to all the standby sites. The exception to this is a farsing, because farsing cannot apply any changes. We need to manually copy the password file to the farsing site, and then it will be propagated to the rest of the standby sites. So the next important thing that we need to do on the primary side is we also need to create something called standby redo logs. Well, this standby redo logs has no significance as long as the database is operating in primary role. However, if there is any role transition that is expected to happen, then we need the standby redo logs to be created, right? So the new primary will be writing the redo data to the standby redo logs on the new standby, right? So for that purpose, we need to create the standby redo logs. And I've also, as you can see on the screen, alter database add standby log file name, path, and the size. That's the syntax. It's similar to creating an online redo log. So some of the parameters that needs to be configured on the primary site. The first section is about the primary. So the important parameter that has to be set will be the DB unique name. So it has to be there. And the next thing is the log archive config. So the log archive config parameter will include the details about all the standby sites that are part of the data guard configuration. And file server on the primary is added just to enable the role transition. It has uh, role to play when the database is operating in the primary role. And we also need to add the log archive. Okay, I think I've missed the log archive dest parameter here. So the log archive dest parameter should be added. If you see the second section, I've added log archive dest 2, where I've mentioned the service as Boston. And async, if you remember, we spoke about the different protection modes. So this is what defines the protection mode. So this is what defines the protection mode in which the data guard configuration has been configured. So the primary site should have a similar entry, right? And we also have additional parameters which talks about when this parameter will be valid. So we can say that this will be valid during the primary role, or we can say all roles, right? So basically we need to have the DB unique name and the log archive configuration and log archive dest2 on the primary site to enable the log transport. And we need to add file server and standby file management to help the primary to transition its role to a standby site, right? And as we discussed earlier, the DB file name convert and lock file name convert should be added if the directory structures are different from the primary site. So the standby file management auto will, what it basically does is if you add a new data file on a primary database, the same data file will be added on the standby site as well. So if you do set it to manual, then we need to manually add the data file on the standby sites. And when you have multiple standby sites, it is going to be a very tedious task. So it is always recommended to use the standby file management as auto. So I've listed out an overview of the steps that will be used to create the physical standby. So the first and most important step, as we already discussed, a physical standby will be a copy of your production or your primary database. So we need to take a backup of the primary database. You can either use any third-party backup tools, or you can use a user-managed backup, which is a copy of the data files as it is. The recommended way to take backup is, of course, RMAN. So you can take a backup, transfer the backup to the standby site. The next thing is we need to create a control file which can be used for the standby, right? So it is not a normal control file copy. So we have to use the create standby control file keyword when we are running the command to create the control file. So we have to use the keyword standby. So that will set the role of the database to standby role, right? And we also need to take a copy of the parameter file. If you're using an SP file on your primary side, you can do a create P file from SP file command, and then you can copy the parameter file to the standby site. And next thing that we need to do is we have to set up the environment on the standby side. So when we say setting up the environment, we are talking about making changes to the parameters that are required. For example, changing the instance name and adding certain parameters. Say, for example, if the directory structure is different than your primary, we have to add db file name convert and lock file name convert, right? So, and we also need to create the standby redo logs on your standby side. So we create the standby redo logs once the database has been mounted, right? So once you restore, copy all the files, restore the backup, and bring the database to a mount state. And if there are a lot of redo logs that are already generated on your primary site, by the time you bring your standby database to mount state, we have to manually copy all those redo logs and apply them on the primary site to keep it as near as possible to the physical standby. Once all the redo logs are applied, all we need to do is just enable the recovery by using the alter database recover manage standby database disconnect from session command. And the moment you do that, the standby, the primary will ship the redo to the standby site, and on the standby site, the apply services will read the redo stream and it will apply the redo to the standby database to keep them both in sync. So this is I've just added a a very high level overview. I mean, I've not included certain steps like listener configuration, copying the password files and so on. This should give you a very, very high level overview of the steps that are involved to create a physical standby, right? So see, when we are talking about a normal physical standby, all it does is it will accept the redo from the primary and it will continuously apply the redo to the standby site. However, we will not be able to query anything from the standby site. So for example, if you want to run any report, you cannot do anything. The only queries that you can run is to query the dynamic performance views. So you will not be able to see anything related to the user data. So for that reason, we have something called active data guard, and it uses a technique called real-time apply and real-time query. So in terms of configuration, it's very simple. There's absolutely nothing complex about it. First thing is you need to have the physical standby similar to what we saw earlier. The difference is if you observe here, after the database has been mounted, we directly started the managed recovery, managed standby. In active data guard, what we do is we will open the database, right? Suppose you have already enabled the standby for applying the redo. You can cancel the redo, and you can you can open the database. And in the latest releases, the best thing is from the control file, we know that the role is standby. So we need not specify open read only. So the moment you just give alter database open, the default way it is opened is in read only mode, right? So just open the database and then put the database back in managed standby. So when you see the open mode from the $V database, it says read only with apply. So the moment you see read only with apply, it means that it is in active data guard mode where it is applying the redo at the same time open for read operations, right? And there is a view called $data guard stats. So you can query this view to understand if there is any lag in the redo, receive, and apply, right? Generally, the value should be less, the lag should be less than 30 seconds. If it is more than 30 seconds, then it means that there is some major delay in your network transport. And for using the active data guard feature, you need to purchase additional license. So the configuration wise, it's very simple. It's all you need to do is just open the database before enabling the recover manage standby mode, right? However, it needs a active data guard license. So we saw how to create a physical standby. Now let us see some of the steps required to create a physical standby. The logical standby. So when as we discussed earlier, the logical standby is based on the objects and it is not based on the physical structure. So what is important in a logical standby is the data types. So we need to check if the data type that is used for creating the tables is supported for the logical standby. The constraint is we should be able to identify the rows in the table uniquely, right? So we do it using the primary key. It's very important to have a primary key because we should be able to extract or identify rows uniquely, right? So there is a view called DBA log stdby underscore not unique. So if you query this view, you can find a list of tables that may not be eligible for SQL apply, right? So you can, before configuring the logical standby, you can query this view and take necessary action. When we say necessary action, you can either create a primary key or a unique constraint, and then requery this view to check if that entry has been removed. And then you can proceed with creating the logical standby. So even for a logical standby, the first step is to create a physical standby. So whatever steps we followed for creating the physical standby still holds good. So once once we back up the primary database, restore it with all the required files, first thing we need to do is bring it close to the primary. So for that, we need to apply, start the redo transmission and apply, similar to how we do for the physical standby. And then we need to cancel it. And then we have to create a directory called log minor directory. So there is a procedure to do that. It's called dbms underscore log stdby.build. So the moment you run that, it'll create a log minor directory, which is used by the SQL apply process to translate the redo stream into respective SQL statements, and then it'll be executed on the logical standby. So if you have to put the database into logical standby mode, we need to use alter database recover to logical standby and the database name command. So this is the command to enable the logical standby mode. So once the logical standby mode has been enabled, we can open the database with reset logs option, and then start the alter database start logical standby apply immediate command, and we can see that the redo transport as well as the SQL apply will be in progress. So there are certain views to check the performance of the logical standby in terms of whether it's being the data is being propagated and applied. So there are two important views. One is DBA log std by events and $v log std by underscore process. So this will actually list out the different processes and their status. So the difference between the core difference between the physical and logical is the logical standby is open in read-write mode. So you can have the data from primary propagated and applied to the logical standby. At the same time, you can modify the data in the logical standby. However, the tables which are part of the logical standby cannot be modified. That can be only available for read only. If you have other tables, that can be modified. So we saw physical and logical standby. So let us now see how a snapshot standby is created. Again, similar to the logical standby, we still depend on the physical standby for creating a snapshot standby. So all you need to do is just use the alter database convert to snapshot standby command, and then you can open the database in read-write mode. Once you open in read-write mode, you can run the real application testing or any other changes that you want on the snapshot standby database. And suppose the snapshot standby and physical standby are far in terms of time. And if you want to bring the snapshot standby to the same time as the physical standby, we have to again convert that to physical standby database. So for that, we have to shut down the snapshot standby, mount it, and alter database, convert to physical standby, and then enable the recovery, right? So the managed recovery process, I mean to say. So it will then discard all the changes that are done, and then it will start receiving the redo stream from the primary and apply it onto the logical standby database. I'm sorry, the snapshot standby database. So we've seen how to create physical, logical, and snapshot, and we also saw some of the parameters that are supposed to be used. So now let us understand some of the key attributes in the parameters related to the log archive test, which will translate to the protection mode that the data guard configuration has been created in. So as we saw earlier, we have three protection modes: the maximum availability, maximum performance, and maximum protection. And there was a note in the previous slide saying the protection mode is defined by some of the transport parameters that are used. So now let us see what they are. So for maximum availability, we have to use, first thing is we have to use sync. When we say sync, it's a synchronous redo transport, which waits for acknowledgement from the standby side. And in addition to sync, we have to use affirm or no affirm. So the basic difference between affirm and no affirm is when we use the parameter affirm, the primary site, or I would say the destination site, will write the redo to the standby redo log and only then send an acknowledgement to the primary site. When we use sync and no affirm, the standby site will send an acknowledgement as soon as the redo is received, It does not wait for the redo to be written to the disk. So that's the difference between affirm and no affirm. And in maximum availability, uh, you have an option to use affirm or no affirm. However, we need to use sync, right? In maximum performance, as we saw earlier, the redo transport happens in asynchronous way. So we cannot use sync. The only option to use is async. And it has to be no affirm, because when we are not waiting for an acknowledgement from standby about the redo transport, it does not make sense to wait for an acknowledgement on the disk write. So it has to be always no affirm. And when we are using maximum protection mode, it has to be sync and it has to be affirm. It cannot be no affirm, right? So usage of these parameters is what defines the mode in which the data guard configuration has been created. So I've added an example here to show how to configure the transport services, or how a redo transport gets enabled. So this is a very important parameter, as we discussed earlier, the DB unique name. And log archive config will list all the standby sites here. And the log archive dest1 always refers to the local redo destination, and the log archive dest2 is what defines the standby sites to which the redo transport should be configured. So we use the service. So here, for example, the primary site is called Boston, and we are using another standby site called Chicago. When we say service, we basically define a TNS entry in the TNS names.aura. So you can define the host name or the IP address, the port at which the listener has been configured on the standby site, and so on. So this will translate to the entry in the TNS name. And async refers to asynchronous redo transmission. And no affirm, as we saw, it does not wait for an acknowledgement from standby for the redo being written to the disk. And valid for, when we are saying this parameter will be effective only when the database role is private, right? And there are some additional parameters for compression. So basically, the redo transport will also use a compression, right? So that will reduce the packet size and also reduce the lag in which the transmission happens. So in this, we also have an additional parameter, log archive dest3, which is transporting the redo to another site called Hartford. So basically, this configuration has 3 databases. One is primary and 2 standby sites. So after configuration, we can check the $archive dest view on the primary site to understand the status of each of the log archive destinations that are configured. So it just takes one parameter to enable your primary database to start the redo transport. So that's the log archive dest parameter. And there is a new feature called a terminal destination or cascaded redo transport destinations. See, in the previous case, what we have done is we have configured log archive dest2 and 3 on the primary site to transport the redo to multiple locations, right? So the responsibility to transport the redo in this case is on the primary, right? So that obviously is a little challenging in terms of managing, right? So to avoid or to offload the burden of redo transport from the primary, we have a new concept called cascaded redo transport, right? So what happens is there will be one standby site which will be designated as the cascaded redo transport destination that receives the redo from the primary directly. Okay, so we should be talking about second point. So cascading standby database site receives the redo from the primary directly, and it then transfers the redo to the rest of the standby sites. So this concept is called the cascaded redo transport destinations, right? So what we are doing in this case is we are offloading the responsibility of transferring the redo from the primary to one of the standby sites. Say, for example, we have one primary. Say, for example, Boston is your primary and Boston 2 as your standby site. Boston 2 will take the responsibility of transferring the redo to, for example, if you have another site called Denver, right? So the redo transport is not happening from Boston to Denver. It is happening from Boston to Denver. So one standby can cascade the redo from primary to 30 terminal destinations. So I've added an example of how to configure the cascaded redo transport. Well, although, as we saw in case of the active data guard, the names are very complex and the whole concepts are very complex. The configurations are very, very simple, right? So for example, if you see here, this is the primary site and I've configured log archive dest 2 to Boston 2. And this is the Boston 2 configuration, right? So here, if you see, the log archive dest 1, as usual, refers to the local site. And here I've added another log archive dest 2, similar to primary. And here I'm using the service as Denver, right? So what I'm trying to say is, from Boston, the redo is transported to Boston 2. And Boston 2 is taking the responsibility to transfer the data to Denver. If you see the configuration on Denver, there's nothing, this is just a 3 database configuration, so there is nothing else to be done. So the parameters on the Denver will be a standard set for a standby configuration. So for example, if there was another site, say for example, Denver 2, I can configure log archive dest 3 and add a similar attributes and specify the service name as Denver 2. So the Boston 2 will ship the redo to Denver and Denver 2. So that's basically about the cascaded redo transport configuration. So we saw how to do the configuration. However, we also need to understand what to check and where to check if there is a need to understand if the configuration is working fine, or say, for example, there was a network outage and the primary and the standby could not talk to each other. So we need to understand how far they are, right? How far the standby database is in terms of time from the primary database. So some of the views are, as we saw earlier, the $v archived status. That will tell us whether the transport is happening to the destinations, and the lock sequence number, which was the last one to be transported. And there is a new view called $v guard process starting 12c release 2. Earlier, we were referring to a view called $v managed underscore standby. The manage underscore standby view will be deprecated very soon. So we should start using the $v guard underscore process if you are on release 12c release 2 and above. Although managed standby is still available on 12c release 2, it is basically available for backward compatibility, which will eventually be phased out. So the $v data guard process will list out each process and the action that are taking, and which was this lock sequence number that they worked on. So this is very important to understand. Say, for example, my lock sequence number on primary is, say, 10. And if I see 9 here, it means that we are up to date, and the process is waiting for the next locks to be shipped. And this is, again, a very important view called $v archive underscore gap. So this will basically tell you how many logs are pending on the standby side. So here in this example, we have low sequence as 7 and high as 10, which means that the missing logs are 7, 8, 9, and 10, right? And there is another important view. It's called $v redo dest resp histogram. This will basically tell us the lag in terms of the redo transport. So we can understand how much time is it taking for the redo to be shipped from the primary to the standby. As we saw earlier, DBA log stdby underscore log is the view in case if you're using a logical standby. So all these three things will help if you're using a physical standby. If you're using a logical standby, we should be using DBA log stdby underscore log. So now let us understand some of the wait events. So obviously wait events are the placeholder for some action that is happening. So it will actually tell us the current status, right? So there are mainly 3 wait events. The first one is called LNS wait on attach. If you see this wait event, it means that the primary is establishing a connection to the standby, and it is waiting for the connection to be established. And the next thing is LNS wait on send REQ. So this is the total time that is spent waiting for the redo data to be written to all the async and the sync redo transport destinations. So this you will see again on the primary side. So LNS wait on detach. So this is the wait event to tell us how long it took for the redo transport connections to be terminated. And we already saw this link, the MAA white paper. So please go through this when you have time. So now let us briefly see how the apply services would work. So the left side here, see, of course, this is the primary site. We have the log writer, the online redo logs, and the archive redo logs. So as we saw earlier, we will establish a Oracle Net connection to the standby site. And the RFS process, the RFS stands for Remote File Server. So this process would receive the redo and write it to the standby redo log files, which are then applied to the standby site. So this would happen when we are using the physical standby. So MRP is the process, managed recovery process, which will be active when the configuration is a physical standby. If we are using a logical standby, the redo data is archived, and then the logical standby process would read the redo data, and it will convert into the respective SQL statements, and then it will be applied to the standby database. So this is a basic architecture about how a standby configuration works. So we saw about the data guard broker earlier. We just saw an overview. So let us now understand a little bit more in detail about what a data guard broker can do. So that, as we saw earlier, data guard broker is a distributed management framework that automates and centralizes the creation, maintenance, and monitoring of the data guard configuration. When we say distributed management framework, you can, if people are aware of the rack, you can compare this to either a SRVCTL or a CRSCTL command, where you can log into one node and administer other nodes. So it's a similar framework. So we can use DG in creating the DG configuration, or data guard configuration, that include one primary DB, standbys. We can also add a recovery appliance to the standby data guard configuration, and we can configure the redo transport services, the log apply, and the log apply services as well. Using the data guard DG broker, we can also modify the existing DG configuration as well, right? And we can change the protection mode using the broker. We can initiate switchover, failover, and fast start failover using the data guard broker. Apart from this, data guard broker also monitors the configuration. It will capture some of the diagnostic information, and it can also report statistics like the redo apply rate as well as the redo generation rate. And in 18C, there are a few new commands in the form of validate. So using the data guard broker, you can validate if a database is ready to become a primary. When we say validate, this has to be done on the one of the standby sites. So when you run the validate database command on a standby site, it will verify the configuration, and it will tell us whether the standby site is ready to take the primary role. And there is also another command called validate network configuration. So this will basically check if your network configuration has been configured properly. And a brief overview about the data guard broker configuration. So as we saw earlier, DGMGRL is the command line interface, and it has a data guard monitor process. It has its own configuration file and a daemon process, right? So when you invoke the DGMGRL, the daemon process is the one that will help in reading the configuration files and then talking to all the members of the data guard configuration. So with this, I've kind of covered a brief overview about the whole data guard configuration. Before we go to a small demo, please let me know if you have any questions.
You may unmute yourself to ask a question, and if there is any question, then you can also type it on the chat. Are you able to unmute? Yeah. We have one question from Hari, and he is asking that failover. After failover, primary instance will complete outage, or we can recover. Are we able to recover it?
Yes. See, that's the difference between failover. Okay. No, failover is a permanent loss. So if you do a failover, you have to rebuild the database, the data guard configuration. Say, for example, you have, say, Boston and Denver. Boston is your primary and Denver is your standby. You, for some reason, you lost the Boston side and you do a failover, right? What you need to do is for Denver, again, you need to build another standby database. So Denver will be your new primary database.
Okay.
So does that answer your question?
Hari, is this sufficient, or you have additional more questions?
Can you see the putty screen?
Yeah.
Okay. So I'll probably wait for another 2 minutes and then we'll proceed with a small demo.
Guys, if you have any question, then you can directly ask or type it over the chat. I have unmuted everyone.
Can I stop this game? Video.
Yeah, what's the difference?
Speaker.
Sir, what's the difference between fast start failover and failover, normal failover?
Sorry, yeah, I was on mute. See, fast start failover is a data guard broker feature. What it does is it'll, based on the metrics and the monitoring capabilities, it can sense if there is going to be any failure soon. And if it feels that, okay, the primary database might go down, it'll do a failover automatically, right? So one of the standbys will be selected to become a primary site. So the normal failover is a manual operation. So we need to run the failover command to initiate the failover.
Okay, thank you.
Yep, no problem.
Okay, Sujay, yeah, I think all the questions has been
All right.
answered.
Okay, sure. So first what I'll do is I will show the physical. Yeah, so, right. You can hear me, right? So first let us have a look at how the physical standby works in terms of the redo, transport, and apply services. Say, for example, I'm sorry, I'm using older release. I tried downloading the 18C yesterday, and there was some issue with my internet connection. It was very slow, so I could not download it. So I'm using 11.201. However, the basic principles are still the same. So first, what I'll do is, say, for example, let me show you, okay, before, So what we'll do is first I'll show you the configuration in which it is connected. The data guard configuration has been created. So if you see here, given the configuration name as NOUG DG demo, and we have NOUG as the primary and NOUG STDBY is the physical standby database. So this is the So I'm seeing this configuration details from the data guard broker, right? So if I add the show configuration verbose, okay, it's so for the show configuration verbose and the show configuration, the output is similar. So let us see the configuration of the database, right? Show configuration. So what I'm doing here, I'm querying the configuration of the primary database here, right? So as you can see, the database name is NOUG, the role is primary, and intended state is transport on. And some of the important things are the lock transport mode, it is async, and the redo compression by default is disabled, and apply parallel is auto, standby file management is auto, and we can see that yeah, so this basically is talking about the basic configuration about the primary database. So let us see how the standby is configured. All right, so as you see, it's a physical standby. It is in apply on mode. So there is no, see, we saw that the data guard broker also monitors some of the metrics like the transport lag and the apply lag and so on. So as you can see here, the transport lag is 0, apply lag is 0, and real-time query is on, right? So what I've done is I've created the physical standby in active data guard mode. So in one command, you can get the complete history or the complete configuration information about all the sites that are part of the configuration, right? So this is about the basic configuration. So just give help, and there are so many options in the data guard broker. So as you can see, you can connect, create create a broker configuration. You can disable some configuration completely if you want. You can edit. Edit is basically equal to your alter database commands, and failover with just one keyword. You can do the failover. In manual method, you need to first transform your standby site to primary, and then convert your primary to standby site in case of a switchover. So a lot of manual work is involved, which can be completely eliminated by using a data guard broker. So all you need to do is, if you want to do a switchover, you just say switchover to NOUG_STDBY, and everything that has to be done will be automatically taken care by the data guard broker. So we will see a demo of a switchover shortly. Before that, I want to show how lock transport and apply services work. So I'm connecting to the primary or the, okay, so this is the NOUG database. By default, the data guard broker is not enabled. So we need to set the DG broker parameter. So let us see some of the parameter. All right, sorry. I was missing the parameter keyword, right? So as you can see, first, all you need to do is set the DG broker start parameter to true. And by default, it will create the required configuration files to store the configuration about the whole setup. So the moment you start the DG broker start, it means that that database is now ready to be managed by the DG broker. However, once you invoke the DGMGRL, you need to use the add command to add the primary and the standby to a configuration, right? So what we'll do is so first I'll create a user, right? First, let us see if the user test exists, right? All right, so we do not have the user test. So let us run the same query on our active data guard, right? So as you can see, we do not have this user on the primary as well as the standby side. So now let us create user test. All right. Now let us connect to the user test that we created. So now let us create a table. I'm going to create a table as test1, and or let us say employee ID, number, or I'll say employee name. Right? So now I'm inserting a name, right? I'm commenting it. Now select star from EMP, right? So I have created a test user. I have created a table called EMP, and I've added a row to the table. All I need to do is For me to transport the the log to the standby, I just need to initiate a lock switch. Oops. All right, now since I've initiated the lock switch, I can see, if you see here, my current lock sequence is 16. So if you see here, the process has already received the log 15 and applying it, right? So now let us see if we have the row on the standby, right? Right? So as you can see here, we have the table EMP created, and the same data has been transported from the primary to the redo, the standby side. And if you see the mode here, right, select open mode from $V database, it says read only with apply. So what I have done is I've put the database in active data guard mode. If I put the database only in the physical standby mode, the data will be transported from the primary to the redo. However, we cannot run the queries on the standby side, right? So this is how the data will be shipped from the primary to the standby side, right? Any questions on this? So the logical standby, on the other hand, works at the table level instead of the recovery at the database level. The redo is received from the primary, and the logical standby process will create SQL statements, and then those SQL statements will be executed on the respective object. So I could not create a logical standby yesterday because of some time constraints, but the overall behavior will be same, right? So if there is any new data on the physical or the primary, it will be propagated to the standby as well, right? So we have seen the physical standby database configuration and the transport as well as the apply service as well, right? So any questions?
Sujay, Anik has asked the one question earlier. As per Anik, in case the standby database is in mount state, isn't in active data guard state? So he meant to say, whenever the standby database is in mount mode, then cannot we consider it as an active data guard state?
No, because see, when we say active data guard, we are talking about user data being available, right? So you might not be able to access the user data in mount state. So the database has to be open in read-only mode.
Okay, I hope.
If you're in mount, it's a normal physical standby database setup.
Okay, and we do not need additional license right?
For keeping it in mount.
Mm-hmm. Yep.
Yeah, it does not need additional license for a physical. I mean, you definitely need the data guard license.
Data guard license, yeah.
On top of that, active data guard is an additional license that is required.
Okay. So if anyone has question, you may ask.
हजुर मैले चाहिँ अब भनेर चाहिँ गरेको हो 16 सम्म चाहिँ हजुर
Can we have the recording of the same?
Yeah, we have a recording. We will provide it very soon. Could you email us at info@nepaloug.com so that we can provide you your recorded link?
Info at
Nepaloug. Info@nepaloug.com. Yeah, Sujay,
So
you can
I'll
move.
show some of the configuration required. I mean, the parameters that are. Yeah. So I'll just quickly show you some of the parameters that were configured.
Mhm.
So if you see here, this is the first one, log archive config. So I'm including the primary and the standby sites here, and the log archive dest. So I'm sending. Okay. So I'm sending the redo data to NOEG standby in async mode, right? So these two are the basic. I mean, although the concepts are very complex, the configuration part is very simple. So what I'll do is we will try to do a switch over and see how it goes through, right? So I'll say show configuration. So we have NOUG as primary and this as standby. So I'll say switch over to this and let us see how it goes. Probably I should include in quotes. All right, so we are now trying to do a switchover. Let us see what's happening at the in the alert log, right? Okay, so something is not right. All right, so something is wrong with the configuration. All right, so I can probably capture the screenshots and or capture a small video after this, and I'll send it to you. But this is as simple as it takes to do a switchover to a standby site. Or if you want to do a failover, just give failover to and give the database name, and the roles would change. So I need to just trouble see and understand what has gone wrong. So what I'll do is I'll fix this issue. I'll capture the screen and I'll send it to you. Right. So
Sujay, Sujay, Ramji has one question. Is that the possible to do gap resolution with DGMGRL? What he is trying to ask is that with DGMGRL interface, can we do a gap resolution? Is there any command for do gap resolution?
See, first of all, gap resolution is automatic in a data guard configuration. The moment the network, say for example, there was a network breakage, and the moment it is reestablished, the gap will be automatically resolved. There is absolutely no manual intervention required. And in the latest releases, what is happening is one standby site can say, for example, there is one primary and say 5 standby sites. The logs were shipped to one standby, and the 4 of other 4 did not get it for some reason, and primary is unavailable. So the rest of the 4 standby sites can even retrieve the logs from the first standby site, which got the redo. So it's an automatic process.
Yeah, in some cases, I have also noticed that if you have a gap and there you miss the archive log, sometimes what happens is that we clean up the archive log. Then in that case, we can do an incremental backup to catch up with the archive log.
Yeah, that's right. See, that is used, for example, the standby and the primary are, say, for example, 10 hours or 15 hours or say 1 day behind, right? So the amount of time it takes to ship all the logs and apply it will be huge. So to reduce that, we have something called incremental backup for standby. So what it does is we have to capture the SCNs. For example, what is the SCN difference between the primary and the standby? And we have to generate an incremental backup based on the SCNs on the primary. You can ship those backups to all the standby sites and apply it to bring the standby as close as possible to the primary. And then you can re-establish the recovery mode. So it actually reduces, see, earlier when we are talking about 10G or 9i, if the gap was too much, the only option was to manually transport the logs and wait for it to be applied, or rebuild the standby. So when we say rebuild the standby, again, we have to take the entire primary database backup, transfer it, and set up the standby. So this is not only time consuming, but it is also a tedious process. So to overcome all that, we have this option of incremental backup for standby. Yeah, that's a very good point, Dilly. Thanks for bringing it up.
And if anyone has any questions? So one of attendees is asking that could you please elaborate a little bit more about the snapshot standby database?
Okay, sure. Let me go back to. Okay, so you can see the slide, right?
Yeah.
All right. So snapshot standby is basically a normal standby database. First, we'll create a normal standby database, and then we'll convert into snapshot standby. See, what happens in a snapshot standby is the moment you convert the database to snapshot standby, the redo from primary will not be applied anymore on the standby. And the standby is open for read and write operations. So you can do any changes that you want to the snapshot standby. Okay. Say, for example, you have a primary and a standby, and you want to test some changes to your data set and see how the application behaves, right? So what you can do is you can convert the physical standby to snapshot standby, and you can do whatever changes you want to your snapshot standby database. And you can redirect, or if you have a development instance, you can redirect your development application instance to the snapshot standby and test whatever you want to do it, right? After that, you can convert the snapshot standby back to physical standby. And when you do that, whatever changes were done, it will be discarded. So it works kind of flashback logs. So the data, the new data or the changed data will not be going to the actual files. It will be maintained in a separate snapshot logs, similar to what happens in flashback. So the moment you convert the database back to physical standby, the logs will be discarded, and then you can start applying the redo from your primary back to your physical standby, right? And then they will both be in sync. So this is the whole concept of snapshot standby database.
I have noticed that while using snapshot database, there is some restore point being created, and with the help of restore point, we will get back to the physical standby again. So basically, it's for the test purpose, and I have seen a lot of companies using the snapshot standby database as for the test purpose and for the updation, all these tests.
Yes.
So basically, and use case is just
data, we have another. Sorry, go ahead.
Yeah, the use case is just for to test and simulate the DR. We can even simulate the DR process. It can be used for the DR simulation also, so that we can verify that all our disaster, whenever there is a disaster recovery, we can fully recover and we can have a fully functional database and application over there. So thank you, Sujay, for the elaboration.
And just to add, we also have something called snapshot clone on Exadata. It is a new feature. So see, the drawback with the snapshot standby is if you want to create multiple copies for different application teams, you need the equal amount of space for every snapshot standby, similar to that of primary copy, right? Say for example, you have HR, you have a reporting team, and you have some other team. They want to test their respective module. We have to create 3 separate snapshot standbys for them to access, right? So for example, we have our primary database is say 5 terabyte. You need 15 terabyte to create 3 separate copies. So to overcome this, we have a new feature on Exadata called Exadata Snapshot Clone, where you will create just one copy.
Is it snap clone? Is it equivalent to snap clone? Because I have seen it, the snap clone. I have tested snap clone.
Yeah, it is a snap clone, yes. So like you will have one copy, and then you will create snapshots on that clone. So if you have 5 terabyte production, all you need is 5 terabyte for the snapshot. And then when you create the snapshot clones, it will be exposed to the application like a database itself, but it will not be a complete database. And any changes done will be maintained similar to the flashback logs. So all the changes will be maintained on the separate logs. It will not go to the data files. It will be the snapshot clone will again be in a read-only mode. So probably you can just go through the documentation when you have time. You'll understand it more clearly. But this can be done only on Exadata as of now.
I request to all that we will provide hands-on very soon on our nepaloeg.com site. So later on you can practice it from the hands-on. We will provide over there. So is there any question left?
If you have any questions, you can probably send it to Dilly, and he can redirect it to me at any point in time.
Yes.
Right?
Yeah. If you email any question over the info, then we will try to reply it. If we are unable and we are not aware about that, then we will forward it to Sujay and he will reply it back. So okay, Sujay, do you have any topic left?
For today, I think I'm done. Maybe if you have any topics you're interested in, we can have some sessions in the future, and I can definitely be part of it. Yep.
Yeah, sure. In our country, we are very little aware about the Exadata and the Oracle engineered system. So definitely, if we get opportunity to learn about the Oracle engineered system, Exadata, then it will be very helpful in our entire career.
Sure,
Because,
definitely. Yeah, we can definitely have a session on Exadata as well. So you can plan for it and let me know, and yeah, we can definitely have a session on Exadata too.
And Sujay, is there any simulation to do on the Exadata, because that we cannot get an Exadata machine to test and all these? Is there any simulator or something else?
Well, yeah, there are few, but yeah, that's again for internal Oracle use. But I can definitely show that to you. Yeah.
Okay.
When we have a session next time, I can definitely show that.
Okay, no problem. Thank you.
Yeah, request you to please set up a session on Exadata. That would be great helpful for us.
Sure, definitely.
Okay.
You can plan for it and let me know, and yeah, we can definitely have a session.
Yeah, sure.
But yeah, one thing is, it cannot be done in 2 hours, so probably it needs a little more time. So we can probably plan for a longer session, and yeah, we can definitely do that.
Yeah, sure. It will be very helpful. We can have a break in between the session, and that will be refreshing to us.
Yeah, sure. So if no more questions, then yeah, we'll probably close. And yeah, before we close, I again want to reiterate that it's a very good thing that a user group has been created, and please make you proper use of it to share the information. And yeah, there will definitely be a lot of experiences to be shared from everyone. So even I will also get a chance to learn from all of you as well. So yeah, and all the very best, and keep the spirits. I do not lose this. It's very important.
Yeah, we won't lose the spirit. And thank you all for the attending this session. And I was not expecting that within the few with a short notice that everyone will attend this session, and I am really excited about it. And we will keep continuing.
I hope that it was useful in terms of understanding some of the new things in 18C, as well as the overall data guard concepts.
Yeah. Okay. Thank you all, and special thank you to Sujay. Yeah, you have managed all this stuff, and I'm very thankful to you for conducting this.
No problem. Anytime.
And we will inform about the Exadata, because we are very new to Exadata. Very least people are aware about it. So we will be very happy with that. Thank you once again.
Definitely.
Thank you.
Yep. Thank you, and all the very best, guys. Yeah.
Thank you.